Okay, welcome to the screencast, third in the series with our multiple angle and product of sum formulas. To finish up that last screencast, number 2, we did get to a result 3 sine x minus 4 sine cubed x, and then I kind of got cut off there. That's not something that you are expected to memorize, just saying. We're not going to put you in a position where we'd say evaluate sine 3x, and then knowing that would help you. It was more actually an exercise to say, can you work with all of these identities that we're putting in front of you? Notice there's a couple of critical substitutions and quite a bit of algebra work. Okay, so just a note on that one before we move into the next part, which is actually called the half angle formulas. So we did have some double, and again, thinking back to the way back times in mathematics, these formulas were likely useful to those folks way back before technology, because again, if they knew the sine ratio or the cosine ratio of a certain angle, then they could now also work with half of the size of that angle. Okay, we're going to put you in a couple of different situations in order to apply these formulas. Again, you don't have to memorize them. They will be provided to you, but you have to know how to work with them. Couple of notes. Notice for both the sine and the cos, it says plus or minus out the front of those. It's not plus and minus, it's plus or minus, and you see why we have that, because as you guys know, depending on the quadrant of u over 2, the sine ratio is going to be positive or negative, right? So if it's a first quadrant angle or a second quadrant angle, that's the u over 2, by the way. U over 2, if that turned out to be a third quadrant angle, then you would apply the negative to it, okay? You know an angle u, and u over 2, of course, is half of that, okay? Notice the formula actually involves the cosine ratio. So if you do 1 minus the cosine ratio of some angle u, and then divided that by 2, take the square root, you actually would have the sine ratio of half of that. So a numerical example, if you somehow knew the cosine of 100 degrees, let's say I gave you the cosine of 100 degrees, you could actually work out the sine ratio of 50 degrees using this formula, okay? Because 50 is a half of 100, of course, okay? You can test these out with 3069 if you really want to, but we're not going to do that. Notice that when it comes to the half angle formula for cosine still involved. Except in this formula you have addition in between 1 and the cosine ratio. Once again, plus or minus involved for the reasons that I've already mentioned. Tan u over 2 actually has two equalities that are both true. Notice just a subtle difference. If we have a term in the top 1 minus cos u, it's negative up in the top. If that binomial is involved in the denominator, it would be addition. And so again, how could you use this? Well, for tangent, I would have to give you both the cosine ratio. So let's say I gave you the cos of 100 and I gave you the sine of 100. Well, you could work out the tangent of 50 degrees if you knew those other pieces of information. Okay, notice for the tangent formula, there's no square root, no plus or minus involved. You don't have to make a decision on the plus or minus, okay? That is the introduction. You're provided with all of those formulas. The first application that we're going to go with actually is a verify. It's a verify style question. So I'll just set that up and then we can take a look at it. Okay, example number 4, actually taking from an example Mr. Gerst did on one of his videos. It's not a textbook example, but I thought it was a good one to recycle back in through here, that verify style. We haven't seen those in a little while. So now actually combining all of maybe the identities that you had already memorized. So you knew, there it is, cosecant and cotan. You knew those, the reciprocal and the quotient, and blending that together with the half angle. Okay, so I got some hints over there to the right-hand side. Shouldn't be too tough of an exercise for you to do. I'm going to pause and throw the solution out there like I have in the past, just to optimize the screencast time. See if you could get all the way there all by yourself, and then come back to see how you did. Okay, well, what you have is on the cosecant side of things, it's 1 over sine u, and then that's because of the reciprocal identity, and then cotangent of that u is cos u over sine u, and it's nice they have a common denominator, so we have 1 minus cos u in the numerator, and you know what, you're done. Because of the half angle formula, that is equal to the left-hand side. Okay, you worked the right-hand side until it turned into the left-hand side, which is great. That's a verify style question. So a quick little bit of review on that one. The second example, example 5, does come out of the book, and it is an evaluate type question. So I'll show you that one in just a second. I just got to set it up. Okay, example 5, using a half angle formula. So in this case, find the exact value of the sine of 105 degrees. Okay, so sine 105 degrees, it doesn't, I guess we're saying, well, I'm going to show you how to use the half angle formula. Technically, 105 degrees is 60 plus 45. So I suppose there is a way to get to this answer. If we just gave you this question, sine 105 degrees, some of you looking at your formula sheet, you might not bother using the half angle formula because you could get there with the sum and difference. Well, the sum, in that case, you'd have to use a sum of 60 and 45. Well, let's see if we could judge if it's more or less work. Okay, so how are we going to use this formula is we have to recognize that 105 degrees is half of one of the special angles, 210 degrees, as you see over on the right hand side. Okay, so again, which would you notice first is likely what would drive your strategy. If we give you this one on assessment, if you didn't notice that it was half of 210, because 210 is not maybe one that is memorized by most students, then you might not use this. But that's just for the sake of argument. Let's say you did notice it because now you've watched this screencast and you go, oh, okay, I can use these half angle formulas sometimes. So 105, well, that's half of 210. Okay, so that means that you can do that substitution using the formula that you see there. Now, I made use of the plus on the outside. Made use of the plus because 105 degrees itself is a second quadrant angle. Remember back to what I said in the introduction. It is positive because of the size of u over 2. Right? You always go by the u over 2, the half angle that you're actually finding, right? If I just asked you off the top of your head, is sine 105 degrees positive or negative, everybody would be able to say without hesitation it's a positive number. Okay, so you don't have to be thrown off by this, but I can see how you could be, because 210 is the angle that you're actually bringing into play to actually evaluate this thing, and 210 happens to be, as my diagram shows, that's a third quadrant angle. Okay, so back to it again, sine 105 degrees, that is going to be a positive of 1 minus cos 210 degrees over 2. So that substitution, that's the easy part. Now we actually have to find the exact value. So this is going to get pretty fractiony and pretty radically. Give that a shot, and I'll do the whole pause and reveal thing little by little. Okay, I better zoom in here. Hopefully you get that far. I've got 1 minus, let's get right and tight there, 1 minus negative root 3 over 2, all of that divided by 2, and all of that under a square root. Okay, so the entire fraction is being square rooted eventually. Why negative root 3 over 2? Well, that's because of the diagram I drew over here, right? 210 is a third quadrant angle, and so we have to have a negative root 3 over 2 for the cosine. Now it is a subtraction of a negative, so I have 1 plus root 3 over 2 in the top. And all of that divided by 2. Now, complex fraction there, how do you simplify that? You certainly can't deal with the outside square root first. You have to first simplify the numerator. So you've got 1, that's the magic number 1, is really 2 over 2. So bring that together, and then you've got to deal with that fraction on the bottom. Let's see how you do with that. Again, doing the whole pause reveal thing. Let's see how you can do. This is definitely getting very fiddly. There's the 2 over 2 that I predicted, and the root 3 over 2. Right? That is now 2 plus root 3 over 2, and all of that is being divided by 2, right? Now there are some more steps, so follow the magic line here. There we go. And let's see if you can get further. What would you do there? Well, that's an entire fraction, 2 plus root 3 over 2, and then in the denominator, there's actually another denominator. It's over 2. So now the same thing is you've got to keep, flip, change. If that's how you remember it, do that and see if you can get to the exact value of the sine of 105 degrees. Okay, doing so, I said we keep the top fraction, I flip the bottom fraction and change that to a multiplication. So you have 2 plus root 3 in the top because it's multiplied by 1, and then 2 times 2 is 4 in the denominator. You could take that one step further, just applying up properties of exponents type of deal here, actually, because this fraction is actually being raised to the power of 1/2 by virtue of being under a square root. So actually square root the top, it just stays the same way, fiddly little fraction that you see there. And then in the denominator you have a 2, because the square root, we take the square root of 4, is 2. That is the exact value. Now, I don't know if anybody's gone to the trouble of actually trying to do the sum difference formula. Maybe that turned out to be easier. You might not actually get to the equivalent looking form like that. Maybe in another video, maybe some bonus content, I can attempt that in live theater for you. We do have one more example of this type that's involving the half angle formula, and I'll set that one up and we can put that on the screencast as well. Okay, very likely the toughest trig equation you've solved so far. This is find all the solutions in that certain interval, so no need for the plus 2 pi n, of this equation, 1 plus cos squared x equals 2 cos squared of x over 2 in that interval. You can't solve an equation if you have mixes of cosines with different multiples, and so you would know, hopefully, that you would have to make a substitution. I mean, I think it's a dead giveaway if you get x over 2. But it's a mixture type of thing again. I shouldn't say quite like that. A couple of videos ago there, when there's a mixture of the multiplicity, if that's a way to say it, of the argument there, if you have single x's and half x's, you're going to have to do a substitution. We did see an example like that in an earlier video. Anyway, this is all about half angle, so thinking that you're already thinking that you're going to use the half angle formula, give that a shot. And again, I'll do the whole pause reveal thing to show you what that's going to look like. Okay, so that is what the substitution actually looks like. You have the number 2, and then you've got all of this thing, the formula, being squared. Okay, now just to show you the algebra is off to the right-hand side on the Jamboard, so you can see it. We actually had 2 cos squared of x over 2. We know that. Okay, actually that notation, just to remind you once again, when this little 2 is hanging in there, it actually means cos of x over 2 times cos of x over 2 as well. This thing is exactly the same thing. That's what's being squared. But when you do the notation in trig, the squared tucks in like you see it there. Okay, now the substitution from your formula sheet that you can see above would go in, and you've got that thing squared. Okay, the plus or minus, I've left the plus or minus in there. It's actually a bit redundant, not a little bit redundant, it's very redundant because it's going to be squared. Saying very redundant is also very redundant. You don't need plus or minus there because it's going to be squared anyway. Okay, so what happens next? I'll do the whole pause reveal thing, see if you can take that a little bit further and come back to see how you did. Okay, I took it all the way down to there. Left-hand side staying all the way the same. I went ahead and, because there were fractions on the inside, just for demonstration purposes, or maybe just a good habit for you to get into, change those fractions into, change those whole numbers into having a denominator of 1 and maybe to keep things straight, which you may have fumbled a little bit, but I'm thinking most of you would have done pretty well there. Because I kind of hinted at it, this, if you have the square root of something and you square it, well then you've just got the thing that was under the radical. Most of you probably pretty good at getting to there. And then the 2's would cancel, right? Because you've got a top and bottom scenario. So you just have 1 plus cos squared x equals 1 plus cosine x. I mean, that has really simplified. Now we're back to one of the more easy, I shouldn't call it like that, easy, but now we're into a more of a fundamentally straightforward situation. We have to consider, how am I going to solve this trig equation? I have cosine x's, both spots. One of them is quadratic. I've got the number 1 on both sides. What would you do next? What would your strategy be next? Give that a thought. Some of you may be thinking divide cosine x on both sides. Others thinking maybe a different strategy. Okay, give that a shot and then come back to see how you were thinking, if that was good or not. Hopefully what you thought was to bring everything to one side and set equal to 0. Yeah, divide away cosine x. We've seen that type of spot where we put you into that, and that's no good. You can't do that because if you had divided away a cosine x, you're dividing away lots of potential solutions. The correct thinking process is factoring, right? Factoring is a good, well, it's not a good thing. It is making use of the zero product property. Okay, so if you have a quadratic equation, the first thing you should be thinking of is factoring. And certainly in this unit, we haven't exposed you to any quadratic formula. So, you know, maybe thinking that always, if you're getting to a quadratic equation in our trig unit, think about factoring. And so hopefully you did that. If you did not, hopefully I've corrected it for you. So bring everything to one side. You've got cos squared x minus cos x equals 0. And you can factor away. And as you can see by the branches here, we're going to have to do the trig part finally, okay? And I'll zoom out a little bit. There is the unit circle. That's come up in a couple of other examples. Each branch is going to be set up equal to 0 to start with, and so then we're going to have to use these ordered pairs around the unit circle. Give that a try and see how you can do. Get all the way to the end. Between 0 and 2 pi, that's what we need to find. Okay, down the left-hand branch, if cosine x is going to be 0, that occurs at both pi over 2 and 3 pi over 2. And then if cosine x is negative 1, I rearrange that one, get 1 to the right side. I'm looking for a scenario where the cos ratio is 1. That means the x-coordinate is 1, and that happens at a rotation of 0. So actually 3 solutions. In this case, there was an equation a little earlier where there was a redundant solution type of thing happening. But in this case, nope, there's another solution. So you got to find all 3 of them. There you go. There's your 3 solutions to this equation between 0 and 2 pi. Good stuff.